If 30 centimeter cube of a gas at 50 degrees Celsius is warmed to 80 degrees Celsius at a fixed pressure, the fractional increase in volume is dash. Solution. Before we proceed, if you are yet to subscribe to this channel, kindly do that so as to get more of these videos as soon as they are being released. So subscribe and click on the notification bell as well. Now let's continue. Looking at the question above, it's a question on gas laws, and the gas law we'll be using here is the Charle's law, which states that the volume of a fixed mass of gas is directly proportional to its temperature provided the pressure is kept constant. And in the question above here, we have the pressure to be fixed. And the question says if 30 centimeter cube of a gas at 50 degrees Celsius is warmed to 80 degrees Celsius at a fixed pressure. So this makes Charle's law to be suitable. Another thing attached here is that we are being asked to calculate the fractional increase in volume. So now we do not know the final volume yet, and we are also asked to calculate the fractional increase in volume. So to get the fractional increase in volume, the first thing we are going to do is to calculate the new volume, that is the final volume of the gas when the temperature is being changed. And to do that, we'll be using the equation derived from Charle's law, which is V1 over T1 equals V2 over T2. So now subscript of 1 here refers to the initial value, while 2 refers to the final values. V and T refers to the volume and the temperature of the gases. So now let's write out the values given from the question. Starting with the initial value, for the volume now, V1, that is the initial volume of the gas, is given to be 30 centimeter cube. Then T1, the initial temperature of the gas, is given to be 50 degrees Celsius. And this will be converting it to Kelvin. So this is equal to 50 plus 273. So this gives us 323 kelvins. Let's not forget the unit Kelvin. So now for the final values, now V2, we do not know the final volume of the gas, so we have that to be unknown. Then T2, the final temperature of the gas, is given to be 80 degrees Celsius. We'll be converting that to Kelvin as well. So we have 80 plus 273, the unit Kelvin. So this gives 353 kelvins. Now we've gotten V1, we have T1, V2 is unknown and T2 is unknown. To get V2, we'll make V2 the subject here. So V2, from the formula above, V2 equals V1 times T2 divided by T1. So substituting the values, we have V2 to be equal to V1, which is 30 centimeter cube, multiplied by T2, which is 353 Kelvin, divided by T1, which is 323 kelvins. Calculating this, we have 10590 for the numerator and 323 denominator. The unit in centimeter cube. And this is equal to 32.8 centimeter cube. So this is not the final answer yet, because we are being asked to calculate the fractional increase in volume. So to know the fractional increase in volume, we need to know the increase in volume itself, and the increase in volume will be the difference between the initial volume of the gas and the final volume of the gas. So say increase in volume V2 minus V1, and that is 32.8 centimeter cube from what we did minus the initial volume, which is 30 centimeter cube. So this gives 2.8 centimeter cube. So the increase in volume of the gas is 2.8 centimeter cube. So the fractional increase in volume of the gas simply means that how much of the gas increases, that is, what proportion of the initial value of the gas increased. So then, to get that, we say fractional increase in volume equals increase in volume divided by initial volume. Which is equal to V2 minus V1, can also be referred to V2 minus V1 divided by V1. So substituting this, we have this to be equal to 2.8 centimeter cube divided by 30 centimeter cube, and this is equal to 0.093, which serves as the final answer. So I think we are being asked to calculate the percentage of the increase in volume. We'll be multiplying this by 100, but since we are not asked to calculate the increase in percentage, we are only being asked the fraction of it, so we'll be leaving our answer in this format without units. So the final answer is 0.093. Fractional increase in volume is 0.093. That will be all. Do not forget to subscribe and as well click on the notification bell so as to get notified as soon as new videos are being posted. You can also drop your comments in the comment section. Thank you.